Good morning, all of you. Good morning. Is it clear?
Good morning, sir.
Yes, sir.
Screen is visible?
Yes, sir. Visible.
Sir.
Okay. So let us start the class. So we have completed introduction to power electronic devices. Now, so first topic we have to enter is a list different types of thyristor family devices. Okay. So before that, we have to learn about the what is the thyristor meaning. So what is the thyristor means? It is the combination of two letters, capital letter thyristor. Okay, thyratron plus transistor. So it is the thyratron plus transistor. You can call as a thyristor. So the why it is called transistor means because it is having a three-terminal device. So that is the reason it is a combination of thyratron plus transistor. So the combination you can call it as a thyristor device. Okay. So here we have different types of devices comes under thyristor family devices, and it is a PNPN device. Thyristor is a PNPN device. That means how many layers are present in the thyristor? There is a 4-layer. It is a 4-layer 3-junction PNPN semiconductor switching device. Okay, it is a what is that? What is the meaning of thyristor? What is a thyristor? It is a combination of two capital letters, thyratron plus transistor, and it is the how many layers device? It is a
Sir, మీ వాయిస్ ట్రక్ అవుతుంది సార్.
is it clear? ఓకే నా అమ్మ అందరికి ఆడియో వినబడుతుందా? Is it
ఎస్
clear?
సార్.
So what is it clear now? Audio?
Yes, sir.
Okay, right. Now, what is the thyristor means? It is a combination of two capital letters, thyratron and transistor, and it is a how many layers device? It is a 4-layer device, and how many junctions are present in the PN thyristor? It is a 3-junction PNPN device, semiconductor switching device. So, what is the semiconductor switching means? It is what is the semiconductor switching means. So it is making or fabricated with the semiconductor device, mainly with the silicon. So that is the reason in a normal case you can call SCR as a thyristor. So because it is a silicon. It is fabricated with the silicon. It is a semiconductor material. So silicon controlled rectifier, generally they are also called as a thyristor. But the general meaning of thyristor is different from your SCR, because SCR is comes under the family of thyristor. So whatever the device which is behaving like SCR, then you can call as a thyristor family devices. Okay, so that is the reason first you have to learn about the SCR, then you will go for another devices. So how many devices are present means you can see a numerous devices, but mainly there are 17 devices you can see here. Okay, all of you make note of it. Okay, everyone please make note of it and make a running notes while lecturing me. Please note these device names. Okay, so what is SCR? Is a silicon control rectifier, and second one is a diode or bidirectional diode thyristor. Diode AC or bidirectional diode thyristor, both are same. So triode AC, triode, tri means three, ode means terminals, three terminal AC device. Diode means diode AC. So what is diode means? Two terminal device. Is it clear? మధ్య మధ్యలో బ్రేక్ అవుతున్నట్టుంది. Now is it okay? Voice. Please respond.
సార్ మధ్య మధ్యలో స్ట్రక్ అవుతుంది.
అదే ఇక్కడ నెట్ కనెక్షన్ ప్రాబ్లం ఉన్నట్టుంది.
ఇప్పుడు కూడా అవుతుంది సార్.
ఇప్పుడు కూడా ప్రాబ్లం అవుతుందా? నెట్ ప్రాబ్లం ఎక్కువ ఉన్నట్టుంది. ఇప్పుడు ఓకేనా?
ఓకే సార్.
So shall I continue?
Yes sir.
Okay, right. So now what are the you just you have any book with you? బుక్ ఉందా అమ్మ మీ దగ్గర, అందరి దగ్గర? ఫస్ట్ బుక్ కొనుక్కోండి. బుక్ కొనుక్కుంటే ఇంకా ఈజీ అవుతుంది, ఎందుకంటే ఇలాంటి ప్రాబ్లమ్స్ వస్తుంటాయి. మీరు ఆ బుక్ చూసుకుంటే చదువుకోవచ్చు. నేను while I am delivering the lecture, you can see in the book also. So and also you can make a note of in your notes. Both ways you can learn here. So that is the main possibility on online classes. Okay, so because in the physical classes we can interact very easily, but in online classes there is a such these type of problems are arising. So that is the reason you have a book as well as a running notes that will help you much more better. So you purchase this MGB publication book, so IE, so that will help you better. Okay, so now we have there are several number of thyristor family devices. Some of them are listed here. What are they? There are 17 basically, but much more devices also there. So first one is SCR, silicon control rectifier. Second one is the diode AC. Diode means two terminal device, and it is functioning in AC only. That is the reason it is diode AC, or also it is called as a bidirectional diode thyristor. And the third device is triode AC, or three terminal device, is a bidirectional triode thyristor. Okay, and the fourth one is SUS, silicon unilateral switch. Okay, it is called a silicon unilateral switch. Unilateral means only one direction. It is a conduct in only one direction. That is the reason it is a SUS. Okay, it is also called complementary SCR, CSCR. Okay, SUS you can also call as a complementary SCR. That means it is the SCR is bidirectional. That it will be controlled rectifier. Whereas it is unilateral, only one direction it is conducting. So it is complementary SCR. Second one, fifth one is the SBS. So what is the fifth device, which is SBS, silicon bilateral switch. That means you can conduct it in the two direction, bilateral. Okay, it is a switch. It is also a switch, unilateral switch. It is also a bilateral switch. It is a switch, and it is made up of silicon material. Okay, so it will. What is the difference between SUS and SBS? Means only one thing. What is that? It is SBS is conducting both directions, whereas unilateral switch it is conducting only one direction. So next one is the SCS, silicon control switch. Okay. Next is LASCS, light activated SCS. What is SCS? Silicon control switch. Okay. So silicon control switch generally it is 4-terminal device. Okay. So we will see in the next classes. Okay. So LASCS means light activated SCS. Next one is eighth one is LASCR. Same thing, light activated SCR. Okay. So it is a light activated SCR. So next one is GTO SCR. What is that? GTO, or simply you can call as a GTO SCR or GTO. It is a gate turn off thyristor SCR. GTO means gate turn off thyristor. That means you can turn off the thyristor with using a gate terminal, whereas in the SCR you can't able to turn off in the by using gate terminal. So but maintaining a load, latching current, holding current, some specific parameters you can easily turn off the SCR, but by using gate only you can turn off the SCR in the case of the GTO SCR. Okay, so what is the ASCR? Next one is ASCR, asymmetrical SCR. The construction is not symmetrical. That is the reason it is a asymmetrical SCR. Next to RCT, reverse conducting thyristor. Okay, SITH, static inductor thyristor. Next, GATT, gate assisted turn off thyristor. MCT, MOS controlled thyristor. PUT, programmable unijunction transistor. It is not thyristor, it is transistor. Programmable unijunction transistor. Next is IGBT, insulated gate bipolar transistor. Next one is ASBS, asymmetrical silicon bilateral switch. So they are the device mainly we have from ASCR. It is 10 up to 10. It is majorly we will talking about the devices. So these are also present, and much more also there. But you have to only remember these device names as well as symbols. Okay. So what are the symbols? Circuit symbols of each device. So try it in your running notes. Okay. So while listening here only, you have to write down these device names as well as the symbols. Very important here. So you also sketch the symbols. They will ask in the question paper. So sketch the following devices: track, diac, ACS, SBS, SUS, PUT, or SITH, LACS, RCT. Like this they will give ASCR. Okay. So you have to learn these names as well as symbols. Very important here. Okay. So first note down these symbols. You can easily understood what is there. Okay, if you see in the SCR symbol, what is that? How many terminals? It is a 3-terminal device. If you know what is the SCR, they will ask what is SCR. SCR is a silicon control rectifier. It is a 3 terminals, 4 layer, 3 junction semiconductor switching device. You have to tell like this. Okay, SCR is a silicon control rectifier which is having 3 terminals, 4 layer, 3 junction semiconductor switching device. Okay, so and it is made up of silicon. Okay, A for anode, K for cathode, G for gate. There are the 3 terminals, anode, cathode and gate terminals. So next one is track. Track, you can see the it is connected diodes back to back. So it is construction. If you also see in the track, it is connected as a back to back diodes. So how many terminals? It is a 3-terminal device. Triode AC. The name itself having the triode AC. Triac means triode AC. 3-terminal device. MT1 as well as MT2. What is the MT1, MT2? They are the 2 terminals. Main terminal 1 and a main terminal 2 and a gate terminal. Okay, you have to take gate here. Okay, so 2 diodes connected back to back. Diode AC, triode AC. That is a triode. This is next one is diac. So if you see in diac, what is the diac? Diode is only 2 terminals device, MT1 and MT2, and you can also interchange these terminals MT1 and MT2. They can also interchange. Okay, this is also very important. The triac and diac, you can change the terminals. There is no difference. Electrodes you can change. So you can connect to MT1 in the upper one or MT2 in the below, or either case you can change the terminals. There is no problem. Okay, in the case of triac as well as diac. So gate terminal is extra in the track. Diac, there is no gate. Gateless track is called a diac. So gate with diac you can call as a track. Okay, same thing. Track without gate is called diac, and gate with diac you can call as a track. Okay, so you can and this is the diac and track. Next, SUS you can see. So SUS is a silicon. What is that? Silicon unilateral switch. So which is also a 3-terminal device. You can see here, and which is a off of the thyristor, device. So you can construction like that only. So there is a anode, cathode, and gate. So SBS, if you see in SBS, what is the SBS? Which is silicon bilateral switch. So bilateral means there is a how many terminals? We have a 3 terminals, MT1, MT2, and gate. Okay. So if you see, you can also draw the circuit, the symbol. Okay, circuit symbol also you can see here, MT1 and MT2 and a gate, and you can also interchange. And what will happen? Sometimes they will also give anode and cathode in the place of the main terminals MT1 and MT2. Okay, you can also write down the what is that anode, cathode, and gate. There is no difference. There is no problem. Okay. So next we have a SCS. SCS is a silicon control switch. Okay, how many terminals it is? 4-terminal device. Remember this. This is the 4-terminal device. SCS is a 4-terminal device. So what is that extra here? Gate at anode and gate at cathode. Okay, there is a gate at anode, gate at cathode. There is a 2 gates. So gate terminals are 2, anode gate as well as cathode gate. So anode gate and cathode gate. There is a 4-terminal device control switch. That means you can turn on and turn off of the SCR. You can control easily by using gate terminals. So that is the reason here gate terminals are present now to turn on as well as turn off. Whereas in the case of SCR, you can't easily turn off the SCR by using gate. Okay. What is the specialty of SCS is it will turn off the SCR. It will turn off the device by using a gate terminal, the cathode gate or anode gate. Okay, so that is the reason SCS having 4-terminal device. So remember this. Okay, one is the extra special quality. So next one is LASCR. So what is LASCR means? It is a 3-terminal device, but you can see here what is this arrows. So what is this arrows? This is indicating light is falling onto the gate terminal. Okay, light is falling onto the gate terminal. Okay, junction, the junction of the in between a cathode and a gate. Okay, so you can see here that will activate, that will not, the name itself having the meaning that it will activate the device by connecting the light, the emitting the light onto the junction between a cathode and a gate. So it will activate the device by activating the light. So that is the reason it is a light activated SCR. That means you can turn on the device by activating the some energy which is in the form of light. Light energy will fall onto the junction between a cathode and gate terminal. So that will activate a number of photons in the device that will activate the turn on the SCR or LASCR. Okay, so this is the not turn on the SCR, and a specialty of this is to light. Okay, so next one is GTO, gate turn off SCR. That means you can also here turn off the SCR by gate terminal by connecting here the gate. Okay, that is a special device which is GTO SCR, anode, cathode and gate. And you can see here two, one arrow is going here, one arrow coming here, so both ways. Okay, you can simply, this is a device which is having the circuit symbol is different here, or gate here two arrows are there. Okay, you can observe keenly, you can see here two arrows, one is upward, one is downward. Okay, so gate terminal having two arrows here, symbol is different. Okay, not like of your normal SCR. Okay, here some arrow is going there, coming also here, gate terminal. So cleanly observe. Okay, very important. So they will ask what is GTO SCR, what is symbol of GTO SCR, like this. Okay, ASCR, next one is ASCR. So it is looking like ACR only, but it is asymmetrical. The construction is different, asymmetrical, not symmetrical. So equally it is not doped. That is the reason it is asymmetrical SCR. And you see circuit symbol is also different. If you see it is shaded one portion is there, shaded portion is there here, you can observe here, and you can draw it is in your notes. Next one is LASCS. What is the LASCS? You can have the same thing, same as that of your LASCR. So same, SCS is silicon control switch. So LASCS means you can have a light activated SCS. So you can how to activate it, that will activated by using a light energy. So it will turn on the SCS by light energy. So symbol also there, same thing, but you have to add the arrows. Light energy is falling onto the junction. Okay, anode to gate terminal of anode. Okay, okay, so that is you can see in the circuit symbol diagram. Next one is RCT. It is a, what is that? RCT, reverse control thyristor. Okay, reverse conducting thyristor, reverse conducting thyristor. Okay, reverse controlled or reverse conducting thyristor. So you can see here the terminal having different symbol diagram. Next one is, what is the SITH? What is SITH? We will see here static induction thyristor. Static induction thyristor symbol is like this. Okay, symbol is like this, some different from your SCR. Okay, next IGBT, insulated gate bipolar junction transistor, IGBT. Important, it is also important, IGBT. So IGBT, what is IGBT? Insulated gate bipolar junction transistor. So you can see here it is a combination of MOSFET as well as the BJT. So the collector, emitter and gate, not base. The base is for a BJT, gate is for your MOSFET. So that is the reason it is a capacitor is present from BJT. This is BJT, this is BJT, and the gate is there with the capacitor, some capacitor combination here. So it is a combination of, that is the reason it is a MOS capacitor as well as the BJT combination. IGBT is the very intelligently they are constructed, because they are combination of both MOSFET as well as the BJT. So combination of both can be they are fabricated, and it is advanced in the power electronics devices, advancement in the power electronic device, because the characteristics of both this BJT as well as the your MOSFET is performed by IGBT. Next, what is the MCT? You can see what is the MCT. You can hear MOS control thyristor. MCT, MOS control thyristor. So MOS control thyristor. So symbol is like this. So what is the PUT? Programmable Unijunction transistor, PUT. What is the PUT? Unijunction transistor, programmable unijunction transistor. So not that much there in our syllabus, the PUT and MCT, but IGBT is present. IGBT is important. So in these devices, SCR, TRAC, DIAC, SCS, SBS, SCS, LACR, G2SCR, ASCR, LASCS, these are very important. RCT, SC, SITH and MCT, PUT is not there, but IGBT is present. So these are the major elements or devices or components is present in the power electronic or thyristor family devices. Okay, is it clear? All of you are listening. అందరు వింటున్నారా అమ్మా?
Yes, sir.
అది రాసుకుంటున్నారా? నోట్స్ రాసుకోండి, ఇంపార్టెంట్ చెప్తున్నా ముందే. నాకు అర్థం కాలేదు, మాకు చెప్పలేదు, సింబల్స్ రావు మాకు అంటే మీరు ఇవి కూడా రాకపోతే ఫెయిల్ అయి కూర్చుంటారు. ఓకే, ఇక్కడ ఉంటే ప్రాక్టీస్ చేపించచ్చు, కాకపోతే మీరు ఎవరు ఫిజికల్ గా లేరు కాబట్టి. సో యూ హ్యావ్ టు లెర్న్ మోర్, యూ హ్యావ్ టు ప్రాక్టీస్ మోర్. ఇండివిజువల్ గా ఎక్కువ ఉండాలి. సెల్ఫ్ మోటివేషన్, సెల్ఫ్ education is more important nowadays because the online classes are going on. Okay, so that is the reason. So inputs are very less. You should collect more and more inputs and you have to perform more. Output is more. It's like amplifier. You should like amplifier. So small input you have to gather more and you have to deliver more. Okay, so that is your role nowadays. ఇప్పుడున్న సిచ్యువేషన్లో మీరు యాంప్లిఫైర్ లాగా వర్క్ చేయాలి. చిన్న చిన్న ఇన్పుట్ తీసుకోవాలి, కాకపోతే పర్ఫార్మెన్స్ మాత్రం అగ్రెసివ్గా ఉండాలి, హై అవుట్పుట్ ఉండాలి. ఓకే, సో దట్ ఈస్ యువర్ రోల్. సో దట్ ఈస్ ద రీజన్ you can also contact on WhatsApp or anything. By phone also you can connect. Okay, so you can ask the doubts, but very important here topics when I were delivering I will give you a suggestion, the important or unimportant, something like that. So you have to focus more on that. That will help you more. Okay, so this the some VI characteristics also there. So VI characteristic we will learn the later. That's you can see here the difference is that you can easily identified from one device to other device. So because of this only they are different components. Because they are perform characteristics differently, that is the reason they are different components. Because as well as they fabricated differently, that is the reason they are performed differently. Their characteristics are different. Okay, so here you can see SCR is something, it is conducting in the first forward direction and it is also going into reverse conduction mode. Again it is conducting the forward conduction mode. Okay, and the reverse characteristic you see characteristics, if you see it is same as that of your diode, correct or not? So it is leakage current, some leakage current, and it is breakdown is there. Here some breakdown will present and it will conduct rapidly. Okay, heavily it will conduct after breakdown. Series the reverse characteristics if you seen, it is almost all your diode characteristics, but the forward characteristics it is something different because you have a some gate extra terminal, the terminal which is there gate which is extra, that is the reason it will performing differently. Okay, if you seen in the next classes I will briefly explain everything about this SCR, how it will behaving like this. Okay, so now if you track also something different, okay, so we will see the characteristics one by one by discussing the each and every device. Okay, so just observe observing purpose, what is the difference. So if you see in the other difference is track it will seen, it will both it is there, it is the mirror image of first quadrant in the third quadrant. It will perform in the first quadrant as well as third quadrant. That means you can conduct in the both ways, positive to positive, positive to negative, negative to positive. That means there are the four modes of operation. Track has the four modes of operation. Okay, So like this we have a, and a diac is same as that of the forward characteristics of the your SCR. Okay, so seen here. So next we will go for construction details of SCR. So what is the constructional details means? I already discussed how many layers device. It is a 4-layer device. How many junctions it is? 3 junction device. So 4 layers means it will perform 2. For example, transistor has 3 layers. How many junctions it is there? Transistor. How many junctions?
Two
Two
junctions.
Transistor has any junction?
Two junctions.
2 junctions.
two junctions.
Two emitter junction and collector junction. So here there are 3 junctions, J1, J2, J3. Okay. So and how many? Because it is a 4-layer structure. It is a PNPN semiconductor switching device. Okay. And how many layers? It is the 4 layers and 3 junction PNPN device. Okay. Now the terminals, how can be seen here? If you seen the construction here like this. Okay. So this is the PNPN device. This is the PNPN device. How many junctions? J1, J2, J3, and gate should be taken at the second P. Second P. It is important. And anode should be taken at the first P. P1, N1, P2, N2. For example, so P1, N1, P2, N2. P and PN you can symbolize like this: P1, N1, P2, N2. So second P you have to take the gate terminal. First P you have to take the anode, and last N you have to take at the cathode. Okay, and in between we have a junction. P to N 1 layer, 2 layers. In between we have a junction. N to P 2 layers, 1 junction J2. P to N 1 junction J3. Okay, like this you can. Okay, so and also if you seen the construction wise, so it is like this. So it is some gate terminals. Okay, you have to take this. Okay, and anode should be connected to the aluminum electrodes. Cathode also taken with the aluminum electrodes. So that means electrodes used here. What is that? Aluminum. Okay, and by triggering the gate terminal. By triggering means you have to apply a small signal, a gate signal or a small signal pulse. You have to apply at the gate terminal. So that is the reason it is a SCR. You can call as a control switch. You can call as a control switch. Okay. So this is the equivalent. What is that? Equivalent construction of a any SCR. PNPN. See here, PNPN. And if you are exactly middle, you connect, cut it. It is resembles like a 2 transistors connected back to back. That means PNPN, NPN, and PNP. Okay. See here, if you see like this. If you see here, the device PNP, NPN. Exactly middle you cut it. Exactly you middle. If you cut, it will behave same like a 2 transistors PNP, NPN. So like this, the equivalent circuit is like this. So it is a PNP device. It is a NPN transistor. PNP transistor. It is NPN transistor. Okay. So this is PNPN device, anode, cathode, gate. Okay. So like this symbolized PNPN device. So construction, it is looks like this. Is it clear? Is it clear or not? Why it is called control switch? Why it is called control switch? SCR you can call as a control switch. Why? Chapandi.
Because triggering pulse is applied.
Very good. That we have a gate terminal compared to the diode. We have an extra gate terminal. There you have to apply a trigger pulse, a small signal or a very narrow pulse which is applied at the gate terminal. Gate pulse you can also call. This is the reason it will trigger on, it will activate, it will turn on SCR. So that is the reason you can also call as a control switch. And the construction wise, if you've seen, it is the, what is that? Aluminum plates are connected electrodes. Okay, so this is the, and you, if you connect, cut into two pieces exactly middle, so it is in the, for example, in the P region you connect like this you will cut it. So there is the it will appears like, just appears like it is a two transistors are connected in back to back. So that is the reason it is a how to, that is the reason the SCR working can be analyzed through two transistor analogy. Okay, it will be analyzed just the purpose of analysis only. Okay, just the purpose of analysis only, we have to go to this device structure. But generally the practical, if you connect the two transistors back to back, will not work as a SCR. But is the, for the reason of your analysis purpose, how we have taken and we have analyzing this purpose. Okay, so if you see in the basic structure of SCR can be divided into a three-layer structure, and the upper three-layer structure you can call as a PNP transistor, whereas the lower one structure you can call as a NPN transistor. And two transistors, it can be terminal as a Q1 and Q2. For example, Q1 is PNP transistor and Q2 is NPN transistor. Here circuit symbols is like this. Okay, so it is also important, so draw it in your notes. Okay, so that means what, how it will be connected back to back means collector of one transistor is connected to the base of the other transistor. See here, the collector of the PNP transistor is Q1 is connected to the base of the second transistor Q2, and the collector of the second transistor is connected to base of the first transistor. So that is the reason you connected back to back. The transistors connected back to back, or base of the one transistor is connected to the collector of the other transistor, and the collector of the other transistor is connected to base of the first transistor. Okay, like this you can connect, and it will work like a theoretically you can see that it will work as a SCR. But what is the reason? Not to purpose of analysis, just only how to turn on and how to turn off only we have to do by this purpose. But you practically, if you see, if you connect a two transistor like this, it will not work as a SCR. Okay, just purpose of the your analysis. So what type of feedback it will be generating here? It is called a positive feedback. The feedback it is here because output of first one is given to the second one, and the second one output you given to the first one. So that is the reason this you can call as a feedback. And what type of feedback it is? It is a positive feedback because you are increasing the energy, you are increasing the amplitude levels. The collector output amplified version of the first one is given to the second one, and the second one amplifier output you are to given to the first one. So it is a positive feedback and it is increasing the energy. Okay, so for example, how to analyze this means you can see here. For example, you connect some input to the base of the second transistor, that means through gate. So what will happen? So the energy is given to the second transistor, and the transistor what is the purpose of the transistor action? The transistor action is to amplify the signal. The amplified signal now collected the collector and it is given to the base of the second transistor. So what will happen to the again the first transistor? The transistor again it will amplify the energy and given to the collector of that transistor, and it is given to the base of the second transistor like this. So that means your energy is circulating here and the energy is amplified and more, and whenever you are off, the base of the or gate of the terminal is off. That means you are not giving any energy. What will happen? Q2 will cut off. The Q2 will cut off means it is Q1 also cut off. Correct or not? So G is not giving energy. That means you are not inputted. That means you are not giving any input of energy. So what will happen? The base of the transistor is 0. So base of the transistor input current is 0. So that means your base, the transistor Q2 is off. So Q1 is also off. That means cutoff mode. Both are in cutoff. That is off switch. It will act like a off switch. Okay. Whenever energy is given, the base of the transistor of Q2 is increases, and also it will increase the base of the transistor of the Q1. That is the reason the Q2 is on, Q1 is also on. That means you can. It is in the saturation. So that means it is acts like a on switch. Okay, very simple to understood, very easy to understood how the SCR will work as an on switch and off switch. That will be analyzed through transistor analogy. So what is there in the circuit means whenever you are giving a smallest energy, small energy is given to the gate terminal. That means if you are giving the energy to the base of the second transistor, that will improve the by using a transistor action, that is called amplification, and it will improve the energy and it given to the base of the first transistor Q1, and it will on Q2 on as well as Q1 on. So both are in the saturation region. So it will turn on, the transistor or SCR will turn on. So it is on switch. It acts like a on switch. Whenever the energy not given to the gate, that means 0. So that means base of the second transistor is off, base of the first transistor also off. Both are off. That means the SCR will act like a off switch. Okay. So if you see in the cutoff mode, when it will action will be both the transistor driven to the cutoff. In this case, the SCR acts like off switch, and it will block the current from anode to cathode. Okay. So whenever the on switch, it is there in the on switch means the current will conduct from anode to cathode. Whenever it is off switch, it will not conduct anything. That means in the what is that? The current from anode to cathode in the forward conduction mode. You can call it as both are on means you can call it as a forward conduction mode. In the forward conduction mode, anode to cathode, the current will flow. So and anode to cathode, the current will block in the reverse direction. It will off. Okay, reverse direction means both are off, cut off. Okay, so that is a blocking mode, reverse blocking mode, or it is called a reverse conduction mode. Reverse conduction mode or reverse blocking mode, the current will not flow. So that is the reverse direction, there is no current flow. In the forward direction, we have a current flow. Okay, it is like same as that of your diode. Correct or not? In the forward bias, you have a conduction. That means anode to cathode, there is a possibility of current in the forward bias mode. And the reverse bias mode, there is no current because both are reverse and both are what will happen? Both are cut off. So that is the reason it is reverse conduction mode. There is no current. Okay, in the forward bias mode, we have a current. So you can consider. Okay, it is acts like a.
Mummy,
It acts like a diode. So in the if you seen the construction diagram, if you seen like this, okay. So mathematical analysis we will see in the next class. Okay. So how this current will flow in the forward conduction mode, and how it will be reverse conduction mode. It will blocks everything. That also you can see by using mathematical analysis. Okay. So that means what is IC, what is IC1, what is IC2, what is IB1, what is IB2. If you seen both, then you will increase how the current will increase, anode current, and how the block will be there, the anode current will decrease in the reverse direction. You will see in the next class. Okay, everyone, is it to understood? Everyone. Are you able to understood? So what is your homework today? What is the homework today for you? So draw the symbols, remember the symbols, draw the symbols as well as the construction details, as well as you have to draw the two transistor analogy. This is your homework today. Okay, all of you. Is it okay? అర్థమవుతుంది అందరికి? ఏంటమ్మా ఏంటి ఎవరు రెస్పాండ్ అవుతలేదేంటి?
ఎస్ సార్.
Right, I will wind up here. So tomorrow I will give the mathematical analysis as well as this old Ampere VI characteristics. Okay, everything I will give. Okay, right. So I will end this session.